Determine the implied domain of each function. When finding the implied domain, there are two things we need to worry about. First, we can't have any negatives under a radical. And second, we can't divide by 0. Those are the two restrictions at this stage in the game we have to worry about. So looking at part A, we know we can't have a negative in the radical, so we need the inside, x plus 3, to not be negative. In other words, we need it to be greater than or equal to 0. Now we solve for x. So we can subtract 3 from both sides of this inequality, and we get x is greater than or equal to negative 3. We've got x by itself, and so this is our implied domain. X greater than or equal to negative 3. If we look at part B, we've got y equals x plus 1 over x minus 2. Now this equation has no radicals, so we don't need to worry about this first restriction. There's no way we have a negative under a radical because there's no radical. However, there is a division. We have to worry about dividing by 0. We need to make sure that we're not dividing by 0. So we need the denominator, x minus 2, to not be 0. So we'll set this not equal to 0. And then we're going to solve this for x just like we did in the previous part. So we add 2 to both sides of the inequality, and we get x is not equal to 2. Now that we have x by itself, we've identified the domain on part B. X is not equal to 2. Let's look at part C now. C is y equals x over the square root of x minus 1. Now here we've got two problems. First, there's a radical, and we want to make sure we don't have a negative in the radical. So the first constraint on this is that x minus 1 can't be negative. It must be greater than or equal to 0. That'll satisfy the radical part. We also have a fraction, and we want to make sure we're not dividing by 0. So we also need the denominator, square root of x minus 1, to not be equal to 0. Now, if the square root of x minus 1 is not 0, that means that x minus 1 had better not equal 0. Now, if we combine these two statements together, this first one says x minus 1 is greater than or equal to 0, but it's not equal to 0. This says that x minus 1 had better be strictly greater than 0. So we've combined these two inequalities into this one final statement in the end, and now we're going to solve this just like we did the previous problems. We add 1 to both sides of the inequality, and this says x is greater than 1. We've got x by itself, and so we've identified the domain. X must be greater than 1. And then finally for part D. Part D has no radical, so there's no chance of having a negative in the radical, and there's no division anywhere in this problem, so there's no chance to divide by 0. That means there are no restrictions anywhere, and so the domain is all real numbers. So we can either write this out in words, all real numbers, or we can write this out in symbols as this bold letter R.